So in today's lecture we are about to see the block diagram representation. Okay, so in this lecture we are going to discuss about what is block diagram, what are the block diagram reduction rules, right? So the control system, so it may have number of components, right? So in control system engineering, in order to show the functions performed by each component, we commonly use a diagram called a block diagram. So the block in each control system, so that represents the functions performed by the control system. So a block diagram of a system, we can say it's nothing but a pictorial representation. Block diagram is nothing but a pictorial representation. It's nothing but a pictorial representation of the system or the functions performed by the system. So each and every component in control system will be represented as some blocks, right? So what are the main blocks present in the control system, right? So a block, it is nothing but, so the block is nothing but a symbol for the mathematical operations on the input signal to the block, so that produces the output. For example, you just see, so here you are having a transfer function, so this is a block, right? So this block represents the transfer function or the functions performed by the control system, right? So here you will be having an input, right? Here you will be having an input and the system will produce as an output, for example B. So if your input is A and it produces an output B, or we can write the output B is equal to A into, suppose if this transfer function is represented as G of S, then this B is equal to A into G of S. Or we can say this transfer function will do some function over this input A and produces the output. This is what the block diagram representation of a system. This is a simple block diagram representation of a complete system. So here this arrowhead pointing towards the block, so this indicates the input, and the arrowhead leading away from the block, it represents the output. So these arrowheads or these arrow marks are referred to as signals to the system. So these are called signals, and this arrowhead indicates the direction of the signal travel. Okay, now the another element in the block diagram representation is the summing point. So you know what do you mean by summing, right? Summing point means adding the signals. So a block which is used to add two or more signals. So this is the representation of a summing point, right? So here this is a summing node, and here you will be representing the sum operation or the subtraction operation, right? Suppose if the input to this summing point is A and another one input to this summing point is B, then the output is nothing but A minus B, because you are adding this signal A and you are subtracting the signal B, and therefore the resultant signal is nothing but A minus B. The resultant signal will be A minus B. So in the summing point you can have more than two inputs, right? Suppose if this point is equal to plus, then the output will be equal to A plus B. That's meaning, right? Next one is the branch point. So what is a branch point? See here in this block diagram representation, so here this G represents, the block G represents the transfer function or the gain of the block, right? So this represents the gain. Generally we will be calling it as gain. So this is a gain block, and the input to the system is A, and the output from the system is represented as B, and therefore this B is equal to, we can write B is equal to A into G, the input into the gain block, right? The output is equal to B equal to A into G. Now suppose if you want the same input, if you want to apply the same input to some other blocks, then you can tap this input like this. So now this point, the signal through this line is also now is equal to A, is it? Therefore this point is called a branch point. Now is it clear? Now a branch point is a point from which the signal from a block goes concurrently to other blocks, or it may go to another block or to some other summing points also, right? So these are the important blocks present in the block diagram representation. So this is also one of the very important question. So here the block diagram consists of a block, right? Next a summing point as well as a branch point. So these are the three elements present in the block diagram representation. Now let us see the rules for block diagram reduction. So it will be easier once you know the rules for the block diagram reduction. So let us see these rules one by one. Rules for block diagram reduction. Okay, rules for block diagram. So rule number 1, this is represented as R1. Rule number 1, combining the blocks in cascade. Okay, combining the blocks in cascade. Suppose if there are two blocks in the system, if there are two or more blocks which are connected in series, for example here the gain block is represented as G1, and you are having another one gain block, it is represented as G2, and the input to the system is equal to A, right? And this system is connected in cascade form or in series form, right? So it is connected in cascade. Therefore the output at this point, is nothing but A into G1, and the final output what you will be getting is A into G1 into G2, A into G1 into G2. This is what the final output from the second block, right? So now these two blocks are connected in cascade. How to reduce this block diagram into a single block? You see, these gains G1 and G2 are connected in cascade. Therefore we can replace this G1 G2 with a single block, right? So representing G1 G2, right? Now your input is equal to A, and the output is nothing but A into G1 into G2. Understood? So this is what the first rule. While you connect more number of gain blocks in cascade, you need to multiply all the gain blocks, right? So you can replace all such individual gain blocks with a single gain block by multiplying all the gains which are connected in series. Understood? So rule number 2, let us see rule number 2. So this rule specifies combining or reducing the blocks which are in parallel form. You just see an example. Your input is A, and this input is applied to a gain block G1, right? And the same input is applied to another one gain block, it is G2, which is in parallel with G1. So this is known as parallel connection, right? So this gain block A, this input A is applied to both the gain blocks, right? Now what will be the output from this gain block? A into G1, right? The output from this second gain block is A into G2, right? Now if these two are added, so now I am adding a summing point here, right? So summing point, this one represents the summing point. So here both the signals are added, so I am putting a plus sign here, and now the output is nothing but a into g1 plus a into g2, a into g1 plus a into g2. Understood? So now we can replace this g1 and g2, these two blocks, with a single blocks, right? So how will you write this a into g1 plus a into g2? So we can take this a as common and we can write it as a into g1 plus g2. Understood? Now instead of these two blocks, we can use a single block, right, with gain g1 plus g2. Understood? Now your input is equal to a and the output is, of course, it is a into g1 plus g2, right? This is what the next block diagram reduction rule, right? Now the rule number 3, let us see the rule number 3. Okay, so here moving the branch ahead of the block, right? Moving the branch ahead of the block. Moving the branch ahead of the block. You just see there is a block diagram like this. The input block diagram with the input A, right? The input is A, and you are applying this input to a gain block G, right? And of course the output from this gain block is A into G, right? Now here you are having a branch point. The branch point, what about the signal at this line? This is also equal to A. How to move this branch point ahead of the block? So I want to move this branch point to this place in front of the block. This is what moving the branch point ahead of the block, right? So I want to move this branch point A to some other in front of the this gain block G. How to do this, right? See here, we can do this, we can achieve this by using, see here, this is your input, you are applying this input to this point G, right? Now I am moving this branch point, so I'm taking the output from this point. Okay, I'm taking the output this from this point, right? But I need the output A from this line also, from this line also I need the same output A, right? What will be the output at this point? It is A into G, but this point, the output from this line also should be equal to A. What you need to do? You need to divide this with the output. If you divide this output AG, with G, what you will get? The output will be equal to A, isn't it? We can cancel out this G and G and the output will be equal to A. So you need to add another one gain block with gain equal to 1 by G, right? Now the output will be equal to what? A. Understood? This is what the rule to move a branch point ahead of the block. Understood? So now we have seen 3 of the block diagram reduction rule. So I am explaining it once again. First of all, two or more blocks which are connected in cascade, right? So these blocks can be replaced with a single block with gain product of all the blocks, right? The second rule is two or more blocks are connected in parallel, right, and added together. So in this case we can replace these two blocks with a single block, that is G1 plus G2. Understood? So the third rule is moving the branch ahead of the block. See here, now if you want to move this branch point in front of this block, here this point, you want to take the branch point from this point, you need to multiply the output line with the inverse of the gain block, 1 by G. If you add 1 by G at this point, you will get the output as A. Understood? The next rule is the rule number 4. see here, it is a rule number 4. Right? So what is this rule? Moving the branch point before the block. Moving branch point before the block. Okay. Previous case it was ahead of the block. Now it is before the block. Okay. Now you see the situation. Here the input is A. Input is represented as A. It is applied to the gain block G. It is applied to the gain block G. Right? Now, what about the output from this block? It is of course A into G. Right? Now you are having a branch point here. Right? What about the signal at this point? At this through this from this line, it is also equal to A into G. Okay, so this is also equal to A into G. Now I want to move this point. I want to move this point. This is the branch point here, right? So I want to move this point before the block, right? So to at this point, okay. But if you take the output from this point, you should get once again the output A into G. What to do, right? See here, the output is A into G. Suppose if you take an output from this point, so I am just illustrating the situation. See here, this is the input. Okay, this one is the input A. It is applied to the gain block G, right? So your output is AG, no problem. Now you are taking the same AG. You need the same AG from this point also, right? What is the signal through this line? It is nothing but A. If you multiply this signal with another one gain block G, what you will get? Once again A into G. This is the rule to move the branch point before the block. Understood? To move the branch point before the block, you need to multiply the same gain block. So in the previous case it was you need to multiply it with the, if you want to move the branch point before the block, in front of the block, you need to multiply it with the inverse of the gain. So here you need to multiply it with the same gain. Understood? Here you see the next rule is rule number 5. Rule number 5. So moving the summing point ahead of the block. Moving the summing point, moving the summing point ahead of the block. Ahead of the block. Okay. Now you see. So I will show you the situation, right? So here, just to see this block diagram, here you are having a summing point, right? Here you are having a summing point. Here the signals are added, right? So this is one signal, it is represented as B, and you are having another one signal A, input signal A. It is applied to the gain block G, right? And what about the output from this point? This is A into G. The output from this gain block is A into G. Now these two things are added so that your output will be AG, right? AG plus B. Understood? This is the situation, right? So moving the summing point ahead of the box. Now I want to move this summing point. I want to move this summing point ahead of the block, right? So where I will move this? Sorry, this is moving the summing point. So this situation is moving the summing point before the block. Okay, before the block, right? Sorry. So now, so I want to move the summing point before this block, right? I want to move this to here. Okay. So now you are applying a signal. You are applying two signals. B and A to another one gain block. The output is A into G, and you are adding these two together so that you are getting AG plus B. Now I want to move the summing point before this block. You see here, so I am drawing this again. This is the input A, right? So I have moved this summing point before the block, right? So see here. this is your gain block, right? So this gain block, so I have moved this summing point before this block, right? Now here the output, final output from this gain block should be AG plus B, AG plus B. Understood? The final output from this block should be AG plus B. Now what this is the input A, this is the input A. So what you need to add with this summing point to get an output of AG plus B. Understood? So here the input is B, another one input is B. Suppose if you multiply this B with another one gain block 1 by G, another one gain block 1 by G, what will be the output from this gain block? It is B divided by G. Understood? If you add this B by G with the summing block, what you will get? A plus B by G, A plus B by G. What is this? So this is nothing but AG plus B, okay, AG plus B divided by G. Understood? So this output here, this output is here at this point, the output is what? AG plus B by G. Understood? Once again you are multiplying the same quantity with the G. So if you multiply the same quantity with the G and G will get cancelled, your output will be equal to AG plus B. Understood? So I am explaining it again. So moving the summing point before the block, so I want to move the summing point here in this place, right? So how to move this? If you multiply the second input with a gain block of 1 by G, with a gain block of 1 by G, and you need to add these two with the another signal A, so that you will get A plus BG, and if you multiply again this signal with the G, you will get AG plus B by AG plus B. Understood? This is what the rule. Now we see the another rule. Moving the summing point ahead of the block, right? Rule number 6. Okay, moving the summing point ahead of the block. Summing point ahead of the block. You see this situation. There is a summing point. Two inputs are applied to this. One is A, the other one is B. Right? Now the output is multiplied with a gain block G. The output is multiplied with a gain block G. Now what will be the final output? Here at this point you will get the signal. These two signals are added, right? So at this point you will get signal A plus B, right? So your final output will be A plus B into G, right? A plus B into G. But now I want to move the summing point ahead of this block. They are in front of this block. Okay, see here how to do this, right? So first signal should be multiplied with the gain G, right? So this signal B is multiplied with the gain G. Understood? Another signal A, this is also multiplied with the same gain G, right? Now you are adding these two things. So that you will get what the output will be. From this the output will be AG plus BG plus AG, right? So your output will be AG plus BG. Understood? Or we can write this is equal to A plus B into G. Understood? So now this is what the rule to move the summing point ahead of a block. Now the rule number 7, right? Rule number 7. So what is the rule number 7? Interchanging the summing points, right? Interchanging the summing points. Okay, how to interchange the summing points? Here you see you are having a signal B, okay, and another signal A. So these two signals are added together, right? These two signals are added together, and you are getting an output a plus b. You are getting an output a plus b. Understood? So now I want to add this a plus b, the resultant a plus b, to another one signal, okay. So it is, so this signal is added with another one signal, it is C, okay. So now here this one is added, this signal is a plus b is added, this C is subtracted, you see this equation, whether it may be subtraction or addition, whatever it may be. So now you see, if it is a subtraction, then the output will be equal to a plus b, okay. The output will be equal to a plus b minus C. The output will be equal to a plus b minus C. Now I want to interchange the summing points. Interchanging the summing point means, so I want to add this signal A and C first. Understood? I want to add this signal A and C first. For that, what I need to do? So first of all, this is your signal A, okay. So I am adding this, then I am subtracting this signal C here, okay. I am subtracting this signal C here. Next, the output is nothing but A minus C. So this signal is added with the another signal B, okay, the another signal B. Now the what will be the overall output? The total output is same as that of the previous one, that is A minus C plus B, or we can write it as A plus B minus C. This is what the rule to move the interchange the summing points. I am just interchanging these two summing points, okay, these two summing points, interchange the summing points. Now the another rule number 8 is splitting the summing points. The next rule is splitting the summing points. Rule number 8. Splitting the summing points. Okay, how to divide the summing points, okay. Now you see here, you are having a summing point with more number of signals, right? For example, the signals A, B and C are there, A, B and C are there. So this C is subtracted or it may be added, right? So the output, now from this summing point, the output is A plus B minus C, A plus B minus C. So I want to make this single summing point with many inputs to summing points with only two inputs, okay. So what I need to do? First I need to add two signals using one summing point. This is the first signal A, right? This is another signal B. So add these two signals first. So the output is now A plus B. Understood? So use another one summing point. Here the next signal C is to be subtracted. So this A plus B is to be added. So the output is nothing but A plus B minus C. A plus B minus C. Understood? This is how you need to split the summing points with many input into summing points with only two inputs, okay. So these are all very simple rules, you can easily remember. The next rule is rule number 9, combining the summing points. Right? The reverse process of this one, right? So here you will be having this signal like this, block diagram like this. You need to combine these two, this into a single summing point. Understood? Can you do this? Yes. So you are having a signal A, another one signal B, right? Another one signal B. These two signals are added and the output is A plus B. Understood? So this is added with another one signal or subtracted with another one signal C, right? So the output is A plus B minus C. So I want to make or combine these two summing points to a single one. the reverse process of the previous one, right? So use only one summing point, right, with multiple inputs. Here what are the inputs? B, A, this to be added, next input is B, the next input is C to be subtracted. So this input is to be added. Now the output is A plus B minus C. Understood? So the next rule is rule number 10. Rule number 10. You see, it is nothing but elimination of negative feedback. This is one of the very important reduction rule, elimination of feedback path. So you know, the in closed loop system, feedback will be there. Okay, elimination of feedback path. Okay, see here, this is what your system. Here the input is R, here the input is R. Okay, so you are there is a summing point with the R is added, right, and you are having a gain block here in this place. It is represented as G. Okay, so the output is represented as C. The output is represented as C. Okay, so from this you are having a feedback path with the feedback gain H. So this H may be there or it may be an unity feedback. In the case of unity feedback system, this H will be equal to 1. So whatever it may be. So let us assume that here there is a feedback gain. It is represented